Hey folks. In the last video, I introduced the rewrite tactic where we reason by substitution of equal things. So if we thought n and m were equal, we could use rewrite to replace all the n's with m's. Now that arrow there is just telling us the direction we'd like the equality to be rewritten at. If n is equal to m, then by the same token, m is equal to n. If we wanted to, shouldn't we be able to turn these m's into n's? And the answer is yes, we totally can. Just ask Cock to go the other direction. Now, I'm going to give you a little tiny bit of advice that I am embarrassed to give you, but is still good advice. It's hard sometimes to know which direction you want to rewrite in. Even I mess it up sometimes. So, if you really believe that an equality should let you change your goal and it doesn't work, try rewriting the other way. I'll show you what I mean in a minute. Okay, in any case, so far we've seen that you can write a little arrow here and it'll tell you which direction to rewrite. If by chance you leave it off, Cock will try to figure it out. It'll default from left to right. It's best to always write it. Okay, let's go to the next proof where it starts to matter. Let's take a second to absorb what this proof means. Right? This says for any natural numbers n and m, 0 plus n quantity times m is equal to n times m. Okay, this seems true, right? This little plus is not going to do anything because it's 0 plus whatever. Equal to n times m seems reasonable. There are different ways we could do this proof. Let me show you a way to do this proof. Now, we've already proved a theorem, plus on, that says for all natural numbers n, 0 plus n is equal to n. So we can use that theorem. Let's reference it. So rather than rewriting by some hypothesis that shows up here in our context, we're just going to rewrite by another definition. This is like calling a function, right? It's just saying, well, look, I already figured this out. Let's just do it again. We saw this with and intro before also. So when we rewrite by it from left to right, the 0 plus n turns into n. Now, thinking about direction here, what happens if we go the other direction? Think about it for a second. If this is what the statement of the theorem is, what's going to happen when we rewrite from right to left? So it found a place where there was an n and turned it into 0 plus n. It didn't rewrite everywhere. It just did one of them. So if in the middle of your proof and you think, oh, let me get rid of this n plus 0 or whatever, well, if it goes the wrong way, if you guess wrong, just go the other way. Now, in the name of candor, I should point out there's another way to do this proof. You can just simplify away the 0 plus and do reflexivity. So, okay, maybe you saw that, maybe you didn't. I don't know where you're at on figuring out how these tactics work. But in any case, what I really wanted to show you was how this direction worked and how plus 0n worked. So below in the text, we've got some text sort of walking through the details of how all of this goes. So like giving you informal proofs that correspond to the tactics we're running in Coq. You may not have seen artifacts that look like this. You may have never seen an informal proof before. That's fine. For now, I'm not going to be asking you to write any informal proofs. We're going to start doing that in the third section of the course. Okay, I hope this clarifies a little bit how rewrite works. As always, hit me up on Zulip. I'll talk to y'all soon.